welcome to our talk, Hit the Road, Jack. Today we're going to be exploring human mobility data and spatial analysis through the story of pop music, which is of course the medium it should be explored through. My name is Helen McKenzie. I am a Geospatial Advocate at CARTO. If you haven't heard of CARTO, we're a location intelligence platform. So we're a tool that people use to make decisions with spatial data. If you want to learn more about us, you can find us in a stand over in the X Theatre. So that's a bit about CARTO, a little bit about me. So I'm a Geospatial Advocate. That means my job is basically to get people really excited about location data. So if you come away from this talk not feeling any sort of excitement about spatial data, don't tell my boss, because that means I've done my job very badly. And I'm joined today by Chris from BT, who I'll let introduce himself.
Hi everyone, I'm a data scientist in BT's active intelligence team, and we work with aggregated mobile network data to provide population movement insights across the UK.
Great. Chris and I cannot hear each other at all, so I'm going to assume that he has finished speaking. Great. So here's what you've got yourselves in for the next sort of 20 minutes, 30 minutes. First of all, we're going to do a bit of an introduction to modern geospatial. So what is geospatial? What is spatial analysis? What do people use it for? And how are they doing this? And a little bit about CARTO and how we hope that we're changing the geospatial landscape. Secondly, you're going to hear all about BT Active Intelligence and how you can harness the power of data and analytics through location intelligence. And then finally, on to the main event, Hit the Road, Jack. What mobility trends can we uncover through spatial analysis? And importantly, how does that relate to pop music? So first of all, a bit from me, an introduction to modern geospatial. So just, can I get a quick show of hands? Who here works with spatial data that has a location component? Interesting. I reckon that's about 50% of you here. But actually, probably more than 50% of you have location data as part of your organization. We actually estimate that about 80% of all data has a location component. So basically a component that says where that thing is in the world, where that thing is happening. And loads of organizations are using location data to basically help them make decisions. Those decisions might be, where should I open a new shop? Or where should I put more of my policemen or my delivery drivers? Or where is most at risk from hurricanes or flooding? So basically decisions that have some sort of where factor to them. But we actually think that geospatial analysis, location intelligence, whatever you want to call it, has kind of been done in a slightly interesting way for the last sort of 20, 30 years. We think it's been quite a siloed part of data analysis. Often people doing analysis with spatial data are using traditionally GIS software, which is kind of siloed from the rest of the data stack. It's different software, it requires different data. Often the people doing it have a different set of skills to those people who are doing data science, data analysis, business intelligence, that sort of wider data function that an organization has. So at CARTO, we think that's a problem. That's a problem for a lot of reasons. It's a problem because of risk of having to constantly transfer data, of people looking at different versions of the same data set. It's a problem in terms of scalability because you're constantly having to look at data from different sources. So we think that the data stack should not be siloed, that geospatial should be part of the wider data stack. This will enable you to work with bigger data, faster analysis, so run analysis a lot more quickly. Improve your data security and governance, because all your data is in the same place. You don't have your database and your geodatabase. And also this will enhance collaboration between spatial teams and non-spatial teams. So that's what we are trying to do with location intelligence here at CARTO. So the main thing about CARTO that makes us kind of different as a location intelligence platform is we are fully 100% cloud native. So if you're using a cloud data warehouse like Snowflake, like Google BigQuery, like Databricks, like Amazon Redshift, CARTO can actually be installed directly inside those cloud data warehouses. So all of the processing you're doing, all of the analysis, all of the visualization is happening directly inside your data warehouse. The data never has to leave. That means you can work with data at an absolutely enormous scale, and you'll see some of this in a second. That also means that you're much more easily able to collaborate with your teammates, the data is more accessible, and that's a huge part of what we're trying to do as well, is democratize location intelligence. Because we feel that location intelligence, location is something we all understand. We're all making decisions with location every single day, so why should the wider data world not be able to do that? So that's partly what we're trying to do. So I've just got a brief video. I have no sound, so I'm hoping I can narrate this for you. So it's really easy to talk about like what a platform is, but it's kind of hard to work out what that is in practice. So this is CARTO. This is what CARTO is. You sign up for CARTO and you get this. We have our spatial data catalogue here, which is a hub of around around 12,000 data sets, one of which you can see is data from BT, who you'll be hearing from in a second. And this data is, you can see it's absolutely massive, so it's probably quite small, but there's 84 million rows in this data set, and we can really easily and seamlessly visualize this at an absolutely huge scale if the video zooms out in a second. So you can see how seamless and slippy this is and how easy it is to do visualizations and analysis at an absolutely enormous scale because of that cloud native functionality. So if this is something that you are interested in, then you can head over to our stand and learn a little bit more about this. But what we're doing here is we're basically visualizing BT's data. This is looking at human mobility, so footfall across the UK. We're using something called a spatial index here to visualize this at a massive scale as well. And if I remember rightly, we're going to zoom in and see what the footfall is like around here. I didn't trust the Wi-Fi to do a live demo, but I would absolutely love to. So we're going to zoom into London now and see how busy things are. You can see another great thing here is as we zoom in and out, the resolution of the data is changing. So that's part of how we can visualize 84 million rows on one map. So we're zooming in to Olympia. If when I recorded this video, I remember where Olympia is, around about here. So you can see what's great about this approach is it means we can work at a UK-wide scale, or bigger than the UK, but also look at data at a really hyper-local level, like we are here. So that's a really, really brief intro to CARTO and what it might look like. So I'm just going to attempt to move on, which I've just done. So that's a bit of an intro about CARTO. Now I'm going to hand over to Chris to talk to us about BT Active Intelligence. Over to you.
Thanks, Helen. So yes, as I said, part of Active Intelligence at BT, and we use EE mobile network data to produce population movement insights. So what's happening to the UK population, where are they going, and where are they? And we're also keen users of CARTO because we're using large amounts of geospatial data, exactly as Helen was describing. Wrong way. What I wanted to quickly go into is how we create these aggregated insights. So how do we go from this data being created on our mobile network to useful population insights that can be used in all sorts of sectors where that might be useful. So it could be government policy, transport, retail, all sorts of different use cases. So how do we go from mobile devices to these population insights? Where every time a phone is connected to the EE network, data is being created about the location of this. This is all data that's used in the general running and optimization of a mobile network. Just so happens it also creates a really nice data set for these population movement insights. So previously, mobile network data, MND, used to just be cell-based. So it would just be, we know this device is connected to this cell, but we don't know anything more about the location than that. So we've got some new technology on the EE network that allows us to estimate a latitude and longitude of each of these device connections, and alongside the timestamp we get from that, we then call these pings of where these devices are. On average for devices we get about 500 pings per day, so that's timestamped locations of where we think this device might have been. And you can start to see how when we aggregate all of this up, this can start to give us a really good idea of where the UK population is and where they're moving. But there's more we can do with that. So if we can start to understand where devices are dwelling, so when they're stationary, and where they're moving, we can understand more about the journeys. So any part between two dwells, stationary behaviour, that are in different places, we then got ourselves a journey. And if we start routing this to the underlying transport network, we can understand a lot more about what this journey is, what mode of transport, exactly what route they took, and then provide more details on the kind of the transport aspect of that. So ultimately, we're building up a journey database of the movement of our devices. So what does that look on a map. On the left here, we've got what we call like a breadcrumb trail of these pings from a device, making a journey from somewhere down Luton, going up all the way to Stoke. So you can see the kind of density of these location points we're getting. And then in a second, you'll see how we then model the route that we think this device is likely taken according to the OSM network. And that's the first stage of identifying whether it might be on train if we've routed it to a railway line, or by road, which we can then segment further to try and identify as HGV, car, etc. And then on the right, we've just taken a slightly larger sample of journeys throughout the course of a day, and the pings are used to create that going into Gatwick, and we've coloured it by mode of transport, so you can clearly see the train lines and even the individual trains coming in as clusters into Gatwick. So what do we do with this journey database? Now, we're not that interested in, and no customers are interested in, just where EE devices are going. It's all about where the UK population is. So we need to scale our EE devices to represent the total UK population. And we do that using the most recent census data, also bringing into account demographics so that we take out some of the market share biases across the country on the EE network. And then once we've got that, we can aggregate up these journeys into useful insights, aggregated insights for customers. I should say at this point, this is all at source anonymized data, so at no point do we have any personal information. And then at the point of aggregation, we're always applying privacy thresholds, so no individual journey or trip can be worked back from the aggregated data. So an example of some of these outputs, from as simple as footfall, so how many people do we estimate to be in a given hexagon that might be down to 150 meters at a given time, all the way up to the complexity of how many people are getting on and off at every single stop of every single train every day in the UK. And because we're also routing to the road network to understand the roads they're travelling on, we also provide kind of link-based road data, so traffic information about every road across the UK, down to kind of the roads just below B roads. And it's this road insights that I want to give a few more example on today. And to bring a bit more life to it, we've linked each of them to a road-themed pop song, mostly from the kind of late 60s to early 80s, which seemed to be the golden age of road music. So first up, Highway to Hell, AC/DC, where we've of course looked at the motorway M62 westbound towards Hull. And the point of this one really is to show how we're deriving kind of traffic volumes and flows at small aggregations, so every 15 minutes through the course of the day, and doing this with mobile network data, whereas traditionally you'd need to maybe install cameras or roadside radar or stuff to get the same sort of information. Next up, back down south, we've got Ring of Fire to represent the M25. So recently there was a series of full road closures between junctions and the M25, caused a lot of disruption, big official diversion routes put in place that the highways wanted everybody to follow. We thought our data is great, why don't we have a look at whether everyone's actually following these diversion routes or not. So because again we're looking at the total journey, end-to-end journey that devices are making, we can do exactly that and have a look at whether people followed the diversion route or not. As you can see here on this map, we found that actually people weren't following the diversion route. Only about 11% on this particular closure followed the official one, suggesting everyone's actually just turning on their sat-nav, following that. It's taking them a different route. That diversion route's not working. So some really nice insights. And I mentioned before that from the data's coming from the EE network, so that's always running and it's always available everywhere there's phone signal. So that's great when you've got any like unpredictable or unscheduled events, maybe like a storm, that you want to retrospectively go back and analyse. So what we've looked at here for Thunder Road is where Storm Babbitt hit Scotland in October last year, and had a look at the road traffic conditions compared to the week previously. As you'd expect, all these areas in red is where we've got a big reduction in traffic. Everyone's staying at home, not travelling as advised. but there's actually 3 or 4 links that see a large increase in yellow there. So we delve into that further, find it's because there was a road closure on the A90, and that's where the traffic's all diverting around. So these have all been examples of just looking at the journeys by themselves, no more information, just looking at traffic volumes, where the journeys have gone. But there's a number of additional kind of attributes and data sets that we can merge with our journey data to make them more interesting and get more insights out of them. So what are these? First, we get some demographic information from the contract, so that's kind of aggregated age bands and genders. We can look at the history of locations of devices to try and estimate their home and work locations. So where have people frequently been? Most frequently, that's probably their home location. Second most, that's probably their work location. Not always true these days, but at a population-wide level, it works quite well. We can also merge with public timetables, so maybe like the railway timetables, get more insights out of it, so assigning journeys to individual trains, get more detail out of it. Or it might be that we're using land usage data, so like, did a journey finish in a shopping centre, and we can get more information about what the journey purpose might have been. And we also receive weblog data, again anonymised through the same process. That's the app and web usage, so we can again use that to add more context to these insights being produced. So I've got a few more quick songs related to roads again, but with some of these additional attributes. So first up, Old Man Down the Road, John Fogerty. So what we've done here is plot using CARTO, where men over the age of 65 are the highest proportions on the UK roads. As you might expect, around the coastal areas, we've got a high proportion. This obviously helps to actually start quantifying exactly what that is. And you also see some more unexpected things. So you can see the M1 here, particularly light green. There's a particularly low proportion of men over 65 driving on that. Don't know why, need to dig into more, but it throws up some interesting stuff. And then going into the weblog data, so we had a look at Uber app usage and estimating what journeys may have been an Ubered ride home. So for Take Me Home Country Road, we looked at trips out into the country from Cardiff that were probably by Uber on a Friday night. So again, you can see largely clustered around Cardiff, but some ending up in the valleys in the countryside. And we also looked at kind of repetitive, frequent Uber app usage. That may represent Uber drivers, and you can then start to plot on a map where those home locations are, where are they clustered. You can imagine doing the same for Bolt or something, doing a bit of market analysis. You could in London maybe do the same with Deliveroo and Just Eat and start to compare where each of these apps are being most widely used and where are the trips happening. Lastly but not least, we've got Don't Stop Me Now, Queen. So what we've done is go and have a look at estimating where electric vehicles are travelling based on, again, the weblog data for apps associated with EV charging. If we see a device using an EV charging app lots, we can then probably assume that lots of the road journeys that device is making is in an EV. So give me a sec if I can get this video working, where we've displayed this data on CARTO. So the darker green is where we've got a higher proportion of EV usage on the roads. You can see that mostly follows the motorways where people are travelling longer distances. And what we'll see next is we can also chuck on the map where the UK service stations are. And then, in addition to that, look at the average distance travelled by EVs at the point of passing those service stations. And you can see how you can start to combine all of these different insights together to maybe work out where is the best spot for future EV rapid chargers at service stations. So where are there lots of EVs, and where have they driven far enough to need charging up at that point? So we did that analysis. So we've looked at all the service stations, compared which ones have the highest proportion, where's good for an EV charger, and we got Southwaite up in Cumbria as the prime hotspot for lots of EV chargers. That's the end of the songs analysis. I'll pass back to Helen for some final thoughts on it. Thank you.
Amazing, thank you. Oh, I can hear myself echoing, that's so weird. Yeah, thank you so much, Chris. That was brilliant. I hope at minimum we've given you some inspiration for your Spotify playlist for your trains home, and maybe at maximum made you think about how you might be able to use human mobility data and traffic data at scale to sort of help make decisions, whether that's for your organisation or for research about music. And yeah, that's pretty much everything from us. If you have any questions, I think we've got time for a few now. But if you'd rather, you can find us in a few different places. So CARTO has a stand. It's Y320, which is sort of down there, turn left. It's right by the big snowflake stand. It's the one with all the maps on it. You can't miss it. So I'll be there, and we'll be, Chris, you're coming there after this talk as well, if you'd like to ask us any questions. Otherwise, you can reach out to myself at hmckenzie@cartodb.com, or find me on pretty much any social media at Helen Makes Maps. And you can reach out to BT Active Intelligence at activeintelligence@bt.com. And if you're around here tomorrow as well, I'm giving a second talk over at the Snowflake stand, all about how to de-silo your data using Snowflake, CARTO, and AI. So definitely come along to that. And I think that's pretty much everything from us. Does anyone have any questions? I think we have a runner.
They're just coming to give you a mic.
Oh, great. Being given arm signals, and I don't know what they mean. Headphones on?
Have you used your data to track how many people are speeding on the roads? Because I'm wondering whether you can get like speed data from how quickly they pass through the nodes.
The answer is no. We haven't tried to catch speeders.
Not necessarily to catch them, just to get proportions.
An estimate of speeds of devices and vehicles, but it tends to work better at an aggregate level. So no, we're not speed cameras.
Can I add a point to that? I think is the data that you have would very easily be able to tell what speed people are travelling at. What's kind of missing from the data ecosystem in the UK is actually what speeds you're allowed to travel at. If you are ever, I'm currently taking driving lessons, and I have a sat nav that tells me what the road limit is, and it's very often mismatched to what the speed limit actually is. So that's kind of, for me, a piece of the puzzle that's missing from the UK geo ecosystem. Thank you, great question. Anyone else?
Yes, I had a question. Can you hear me? Oh.
No? Oh.
Hello?
Oh.
I have a mic. Can you hear me?
Yes.
I can. Yes, but I can't see you.
Hello, over here.
Hello.
Hi, I had a question around the data that you get from EE. So obviously you're dependent on their data quality being pretty good. So what would you say is your level of uncertainty around, for example, you're using their location data to know how many people are in certain areas. How much do you know that is due to people actually being there versus, I don't know, lack of signal, for example, because maybe lack of signal could dictate that not many people are being picked up in certain areas of the company. So is there a certain level in certain areas of the country? So is there a certain level of uncertainty there?
Yes. Each individual ping, it's not kind of the sort of accuracy of GPS. We're not pinpointing people to kind of 5-10 meters. We tend to say in urban areas where the cell network is denser, it's maybe accurate to about 100 and 150 meters at an individual ping level. Once we're doing lots of processing, that kind of narrows it down and gives a better estimate. Yeah, it tends to vary slightly. It varies with the density of the network, so slightly higher in rural areas and better in urban areas.
Hi, it's Chris. Quick question about privacy. Do the customers have to opt in for the data to be used?
Sorry, it's tricky with headphones on as well. No, so all the data is collected from the mobile network, so it's not being sent from the device at all. So it's not an opt-in, opt-out thing. This is always being collected as part of just running the mobile network. All the data we receive is anonymized before we get it, so we don't get any personal identifiable information with the data.
Great, I think we have another question. Oh.
Hi, how long have you been collecting this data for, and have you had any seasonal patterns that you have noticed yet?
Yes, very good question. So in its current form, we've had this data since about May 22 now. Previous to that, this is mobile network data at a kind of cell-based level. It's been going for probably over about 10 years now. So yes, we've looked at lots of seasonal patterns. It becomes, obviously, a mobile network is ever-changing. We're bringing in new 5G. All sorts of different technologies are changing, so it's difficult to do really long-term seasonal analysis. But over a couple of years, yes, absolutely, you see lots of patterns of within it.
How about smaller locations, say a conference centre or arenas or stadiums? Can you track movements and insights of people moving around those types of places?
So we would say, sort of at a conference like this, we would say give pretty good estimates on number of people attending it, but not where within the conference they're going. So I think actually one of the slides I put up earlier had the same idea as Helen. We showed the trend through time for over here, and you can very clearly see the days there's obviously been a conference on and roughly the attendance, but we wouldn't start going how many people came to this talk based on it at all.
Hi. Hi, I have a question regarding the commercial value for BT to have an active intelligence. So what does this data use? Is this to help like public service improvement, or what is why would BT invest in using CARTO to have this intelligence for the reason? Thank you.
Yeah. So it's exactly that. So we work with lots of different government bodies for things like optimizing the rail network. So Network Rail is a great example where we provide them information on how many people on all their trains, and that's not a data set that they have access to through other means. They don't get all the ticketing data. And then the value with CARTO is all about visualizing this data. It's all very spatial, and it provides a great tool for getting across how powerful it is.
Great, and I just add to that as well. As you hopefully saw earlier, we have a data hub that has around 12,000 data sets on it, and human mobility data, I'd say, is one of our most sort of cross-functional, cross-vertical types of data that you can get, because if you think about most types of problems that you need to solve with spatial data, human mobility data can help, whether that's where should I put my shop, or how do I need to better plan my telco network around events that are happening, or anything like that. Being able to know where people are, when they are, being able to predict it, really can help you optimize resources, make site selection decisions, loads of things. So I feel like it's a really, really valuable resource, absolutely. Maybe we have time for one more question?
Yeah. Just on the use cases. Yeah. So do you have any use cases in logistics industry? So let's say a logistics company planning their routes and what routes they should take basis the spatial analytics or the journey in terms of journey planning.
Yes, absolutely. It's a really nice use case. So obviously we're across the whole UK, so we can give really insightful data into the traffic conditions, but then also the times of day. We start to break down into HGVs, so that they're particularly useful for logistics world as well. So yeah, there's all sorts of patterns you could use for that.
Great. I think we have to call it there. Unless there's one more question. No? Okay, in which case, if you do have questions, here's where you can find us, so please do come and say hi. And thank you for coming for our talk. Enjoy the rest of the event. Thank you.
Thank you.